Oh, hello
We're
again.
live, and
Looks
I
like
think audio should be good.
I
Please do
probably,
let us know in the comments if Andy's audio is good, because we've tried and tried and we believe his audio is now good. So yes, please do let us know if his audio is good. And of
shall I
course,
just
if you have
say
any
some
questions,
things? Probably,
say some
yeah.
things. Introduce yourself,
Yeah,
Andy.
I'm Andy Faisal. I'm the CEO of the company. I happen to end up in watches, and yeah, we are about to talk about my favorite topic about how to regulate watches from the outside. That's what we are talking about, and I hope that someone tells us if it's okay.
We
And I
do.
hope also
We've
my
got
computer
I
is.
can hear you. I can hear
Ah,
you, which is good news. So
yeah.
we have mastered Andy's audio. We got it all corrected and sorted. So yes, this is going to be the second run of the update about the Quest to Zero project. And of course, that involves both the MicroReg regulation technology and also the Revolution 3 watch. So Andy, let's make you say things seeing as your audio is working, so we can move to that first slide. So
Yeah,
this
I
is
have.
a
Yeah,
this
I
is
mean, that's
an image.
yeah, that's an image of the watch. I have the watch also here, and I have the prototype number. I don't know how much here, which actually shows micro-rack operational in the movement, and that's what we are going to look at today. We also I just received from Silvan today the message that there is also these printed discs around, but I don't have them with me because I built it into the watch. So we have something for the next time to show. And yeah, it's the exciting day. So what do we overall look at today? I'm switching that to that next slide. So that's the watch I have here. You will see that live under my microscope camera thing. You will see in the middle this built-in MicroReg system, which has this little prototype actuator. And on the right side, we have a relatively mature design of the whole application, which you can use then with your smartphone, and you put your watch on it and you send this electric shock as we predicted through that watch in order to adjust it as we want it. Of course, you need to figure out, first of all, if the watch is off. So we can't solve all problems for the rest of the world, but we can solve a lot of problems, I think. Yeah, Dave, how you are in Glasgow at the moment,
Yep,
preparing for our trip, I guess.
we are. Yes, we're getting ready to travel over to San Francisco to the Wind Up Fair, which is happening this weekend, the Friday, Saturday, Sunday. And we've got a few other little events planned in and around that main event while we're over there in San Francisco. But really, today, what we want to do is get a good broadcast out about this update with MicroReg. As Andy said, we've moved on considerably in the last few months. We've been a little bit quiet, we've not said too much, but what we have managed to do is integrate all of the components that we were looking to fully integrate into the K2 calibre. Previously, we have demonstrated a proof of concept and a proof of application model, which
Yeah,
is best described as a flatlay. It kind of stuck out the side of the calibre a little bit, but it showed everyone how it worked.
I
We've been
actually
working
can show
hard
that
with the engineers to
if you
actually
want.
fully integrate it into the calibre now as well. There's a couple of images on the screen there of it. You can see on one side the bottom, which is actually the
Mhm.
dial side. That shows you the actual micro actuator. That's of course done by Mini-Swiss, our partners in this. And then on the right hand side of the screen, you can see the new bridge piece, which will eventually have MicroReg wording engraved onto it. But you can see the little swan neck regulator coming down there and the adjustment pin. And this is all fully working. When we first went live with this, which was last Thursday, that was around about a week after we finally got it fully up and alive. So it's just over a week old now
Yeah,
and it's running, but Andy has got the original
yeah.
concept here. Now
So
you
you
can
see,
see that up at round about that 10, 11 o'clock area, on the right hand image, you can see that assembly, which is the proof of application of the technology to prove that it actually can work and that it can have an effect on the regulating organs of the watch. But on the left hand side of that image, you can see all of it now fully baked in, to the movement, none of it sticking outside the edges of the movement. And of course, the big feat was to maintain the thickness of the movement so that it doesn't add any bulk to the movement. And they've
Yeah.
successfully managed to do that. That has been primarily Marcus in the engineering teams. That has been his breathing day and night for a good few months now to get that done. And of course, with parts coming off of design and being produced, we've got a few videos later, I think, Andy, to show
Yeah.
folk of some of those early components being made.
If my
But
CPU can handle them.
yeah, let's not try and crash your
I'm
computer.
very careful, you know, I want to be very careful with that computer
Slowly,
so that we
slowly.
don't get
Yeah.
kicked out, because I'm waiting actually for a new one. So, but
Yes, we
what you see here
were a
probably
couple of
also
minutes late in
interesting.
starting.
Yeah, this is this device up here. Yeah, that's actually the that is a prototyping device with a motor controller connected to USB, so that we get our power. And when I press that button on the one side, then it will actually send this shock as if it would be from external through a connecting system. Just for the ones who still don't believe, there will be no electronics in that whole system. It's just pure mechanical magic, piezo ceramics moving around when they get a shock.
Best way to describe it is if you're looking at the movement or the caliber on the left-hand side of your screen here, the white square, if you pretend that that's the case of the watch, so that's the case of the watch, and then the tool, which is a little bit up in the top left-hand corner, that will be the interface which the watch will be sat on in order to apply the shock to the watch, which in turn makes the adjustments to the regulation. So yes, indeed, that hopefully you can see the difference between the right and the left there. Quite a clean looking movement on the left. You're looking at this image now. This is the top and the bottom of the movement. So as I mentioned earlier, on the right hand side, that is what's traditionally known as the bottom side of the movement, and on the left hand image, that's the dial side of the movement. But of course, in this Revolution 3 watch, the movement's upside down in the watch. So what you're actually looking at through the front of the watch is what you would normally be looking at through the case back of the watch. That's the bit you would see with this little silver, almost triangular bridge piece that holds everything in place.
Do we want
yes,
to have
Andy,
a little bit of a look on that watch? We have it here on the
Yeah.
table also. So, magic, here you are. So, there we go. That is, of course, not built in yet, because what is the main job here right now? Trying to figure out small details, improvements. Where do we actually have to have these cutouts? How can we make them bigger? Does everything fit in from the rear? Because it sounds like just a couple of hands and things like this, but at the end of the day, there's still a lot of fingerprint here. Sorry, I'll do that, clean that.
Clean, clean, clean.
To see, I mean, you know, it's always in daily use. So all these kind of mechanical things need to work out properly. And here you can see this beautiful greenish bluish finish, depending on how the light is coming. I think I have a little bit of a yellow light here. That's why it's coming a little bit more greenish. When you have a more colder light, it's more bluish. You can also look at it from a different angle here. So
what you're also seeing here is the second
so
generation.
Here you see it's more bluish, depending on how you move it around.
See the colors there, Andy?
Yeah.
You're also looking at the second generation prototype here as well. The prototypes we were showing were the first generation case, but you may, if you've got a keen eye, notice a few of the changes here. So the interior rehot ring, which has got these little cutout windows on it, is now in a kind of mid-grey colorway, and it now has a nice angled slope where it's coming in from the outer edge and it slopes down slightly to the caliber, which just gives it a slightly more open feeling to it. And the window at the bottom at 6 o'clock, where you will be telling the time, you can see there's a beautifully handwritten number 7 on this one, because these are just prototype discs. But we've now put a little chamfer on either side of this window, which does help to open up that window, making it a little bit more visible. Andy did mention earlier, we now have received some of the second, third generation of the prototype time discs, which actually have the minute markers and the numbers printed on them. That will be in a future live that we'll do probably in the next couple of weeks, where once we get these built into watches, Everything about this, though, has everything that you will expect to see. So these are getting, I would say, what, Andy, 97, 98% towards the final aesthetic image.
Yeah.
I see someone's actually said in the chat, who have we got? VW Westphalia Synchro says the Rehot looks so much nicer. Yes, we all agree.
It is.
We felt that the first one was a little bit
Rude.
cumbersome. It wasn't quite
Yeah.
as refined as it could
Yeah.
be, and it's definitely getting a little bit more refined as we move on. The next prototypes in the cases will, of course, have the touch points on them that will allow the tool to touch the contacts on the case to allow that resonant frequency shock to get through. I noticed you'd also put a shock, so you don't want it to be shockproof. Well, yes, maybe Andy uses the word shock because he loves that little meme of Homer Simpson getting an electric shock to his heart. But yeah, obviously it's a very, very subtle resonant frequency that gets applied to it, which in turn is what's used to command the movement of that mini Swiss mini regulator or actuator.
Dig out Homer
part
somewhere.
Oh, he's in there somewhere, isn't he?
Yeah, he's somewhere there.
Maybe you can show them actually working, Andy. I know you've got a couple of little videos, and then we can also, maybe after the videos, we can show them it working in real life.
Yep. 1 second, as long as I'm loading some stuff here. Where are we right now? Should be there.
Yes, Mike, you're right. We're very all happy that Andy has got his mic fixed, and we won't embarrass anyone by saying what was wrong, but we got to the bottom of the big technical issue.
It really hurt. I was really suffering last time. I said, "Shit, no, you don't really want to be live with a robotic voice and completely incapable of handling the situation." But
we got there. We got there.
You did fine, yeah. I mean, you really covered up the whole problem very well. And let's bring up Homer for a little bit of fun here, yeah. Wait a second. Screen. There is our friend Homer. Yeah.
There we go.
Homer is doing actually a little bit of
to get his heart back in synchronicity.
That's exactly what we in fact do. We are sending this shock through this watch, depending on what signature of shock we have. That will move the thing left and right. And so we are all interested, I guess, in seeing how that really works. Let me bring up some. I think the first time in standard movement first shot is interesting. Let's do that. No, I actually opened the wrong one, I think. But we shouldn't be that picky now. Need a little loading here. Coming in a second.
Yes, let's not crash the computer.
Yeah, we also have sound there. Yeah.
Here we go. So what you're looking at here is, this is the screen of the microscope with this movement underneath it. This was on the day that it came alive, and you can see what you're effectively looking at here is the backside of the caliber, and you can see in the middle of the screen, pretty much bang in the middle, that little pin, and then the little round gold pin just underneath it. That is the part that is moving. You can see it moving now in the video, and below that you can see that it will move up and down, either adding or removing advance or retard within the actual.
I actually have another one of those videos. Let me just, I just need to, I figured something out. I need to open actually those videos with photos and not with video, because then it draws less of CPU stuff.
Doesn't try to kill your computer.
Yeah. Here you can see it much bigger style.
So just round about the right hand side of the image here, you can see that pin, and you can see the swan neck regulator, and you can see that moving as well.
Yeah. So
there we go. And this all being moved by receiving that little resonant frequency signal. Two different signals, one to command advance and one to command retard, which will then have the effect to move that swan neck regulator, and of course order to be able to make those adjustments to the regulation. Now what you're seeing here are quite aggressive movements. each individual movement in the final product will change the regulation by 0.1 second. Now, in the case of this, it moves quite a lot. These are quite coarse movements, but it means that you can actually see something happening. If it was just to do the 0.1, you wouldn't see anything happening. Exactly. We're not exactly sure how much these individual swings are, but these are probably in the 5 to 10 second per movement adjustments at this point in time. And now what we're doing is working with the software in order to refine the control to allow us to make those extremely fine adjustments.
I think I would like to show a little bit how the mood was when it first time did what it should do. I have a couple of pictures here. It was really, you know, these kind of things which happen not every day in a company's life. When you put something together, and in fact, for me, I would say it's 10 years. It's a 10 years dream coming true that we, since we managed to come around with K1, I always had this worry that the whole regulation problem will kind of eat up all our margins and cost and everything. And then you send out the watches, you get them back because every watch runs different on every wrist. And that was something which was really like, we need to find a solution there. We're making good parts, but we need to have a better solution for this problem. And there was never this idea and never this technological combination available. And out of a sudden, you know, it goes like that. And in less than a year, we managed to get into this really operational tool, which is fit into a regular movement. So technically, we can equip a K2 movement at 2.9 millimeter height without any technical change on the movement. And that is, of course, a huge achievement that this fits into there. So everybody was there. And of course, we took a lot of, that's Francesco from Mini Swiss and Cedric, who actually, let's get some of the core team members who try to get stuff going. And that's one of these shots which I just showed you. So that is really, when that was all the crowd was around.
This was the video of when it was happening. The video is a little bit shaky, but this is when we were literally witnessing it coming alive for the first time in terms of coming alive in the fully featured built-in package.
Yeah.
One of the questions being asked actually is how many seconds is it spanning? Obviously, we already produce our caliber sets to run within COSC, and the vast majority of them are also COSC certified individually, which of course means that -4 + 6 second range. That in itself is already a fairly significant challenge to get your production calibers all running within that spec. You have to be producing very well-made, very high tolerance parts in order to achieve that. This will allow you to make adjustments probably around about a 10-second window either way.
I have some things here.
What are you doing with the broomstick here?
I said when this...
Andi,
so that was a very interesting situation because I said, German or English? We just let you hear it actually. I think it's spoken in German.
Okay. What are you doing with the broomstick here?
I said, when this turns the first time, MicroReg, fresse ich einen Besen in German. That's called I eat the broomstick. So I need to eat that broomstick now. Doesn't taste very good.
Yeah, this is when Andy was making a promise he would eat a broom if it works.
In German, you say that actually, fressen Besen, this means you're so amazed that you have to actually eat that broomstick. And I did that because I had a small doubt of probably, I don't know, 1% that something goes wrong, but it turned out that this wrong 1% actually vanished and it worked. And so everybody was super happy. I have a couple of other of these videos there. So see you there.
Yeah.
Everyone says that I didn't work.
But yes, that is us recording, getting it working. But that was a great day. And for all of course, the customers that have supported this project from the start, whether with the supporter vouchers, of course, also been able to put down and pre-order one of these watches. Obviously, hopefully this gives you even more confidence that this is real, it is coming to life. And for anyone that's maybe been waiting to see how it develops, again, hopefully this gives you some indication that we have really moved forward over roughly the last 6 to 9 months from when we announced this project. This is where we're at now. In typical HORAGE fashion, we are running ahead of the curve, shall we say. We are running slightly ahead. Obviously, we want to still have a little bit of conservative nature about us, just to make sure that other issues don't come up. The next big challenge, of course, is getting the software stack for the tool ready in order to make those fine adjustments. But Andy's now zooming in on one of the movements live here.
Yeah.
And
we like
are you able
challenges,
to?
the demo
is it
effects.
powered up, Andy?
It should be powered up. At least it was operating before. So I just wanted to show it. Oh, I didn't wind it. Do I need to wind it, or it's okay? Yeah, I think it's okay.
It's okay. Yeah, it doesn't. Yeah. The balance doesn't need to be running.
Yeah.
And Andy's
So
going
you
to
see,
apply it. There we go. That's Andy applying the frequency to it, and you can see it moving there. And this is being done in real time now that we are pushing it out. So you can see that what you'll see is, if you see the pin, you'll see that the silver, the highly polished silver wheel, it's got a little red dot in it that's just come into view there. That is the part that effectively is turning in order to be able to push that little pin against that regulating arm. Of course, the MicroReg little actuator is tucked underneath the balance. That's on the back side.
Yeah. Crazy
there
stuff.
We go. Yeah, it works. It's alive. It's a bit like voodoo and black magic,
so you
but
see,
it definitely
when I
works.
just press one time, it's this very, very small adjustment. It is so small that you hardly can see it, but this distance already makes a difference of, let's say, probably, I don't know, 2 or 3 seconds. So we are actually adjusting in a level, I would say, sub-micron level. That is the target, to be able to do it in this way. And I think we are pretty good at that.
Yes. In the real world, when you're making adjustments of 0.1, 0.2, 0.3 seconds, you literally will not be able to see anything move. But that is all of the plan in the future. Of course, that tool, Andy showed a picture of it at the start. A few changes there as well. We originally showed a mock-up of a tool that had some buttons on it, but we've made a decision that the tool itself will utilize the computing power of one of the most powerful things that everyone carries with them every day and forgets sometimes how powerful it actually is, which of course is their mobile phone. There will be an app-based platform that will allow folk to make the adjustments. So instead of having to plug it into your laptop or your computer, you'll be able to use the power of your processor on your phone in order to make the commands and make the adjustments on the watch. But also the material itself, in terms of the tool, will have a microphone built into it, which wasn't something we originally envisaged, but that microphone being built in will allow us to take note and registration of exact parameters of the watch, which will allow us and allow you, of course, with the tool to make very precise adjustments to the watch in real time.
So basically that's how it looks here.
Actually, yeah, someone's asking a question. Will you keep some form of dot indicator so we can see the adjustment working? That's something that we haven't looked at, but to be honest with you, the app is where it will get the information. So the app will register how much it's been moved, in which direction it's been moved, and you will be able to have effectively a log of information that will dictate what is being adjusted. So yes, you will be able to do it. Even if we were to put a dot or a mark on that wheel, the reality is it moves such a small amount that it would still be almost impossible for you to determine whether it had or hadn't moved. What we need is a software system that registers it's applied the given frequency to move it in a specific direction for a given amount of time equals a given amount of adjustment, but all of that information will be logged. So you will be able to keep a document to prove or to show what has been adjusted.
it's also for us to figure out what actually, well, not for us, I mean for you. I don't want to listen to anybody. There's no server-sided exercise, but on the long run, it is interesting for optimizing further chronometry. If we have the data available and you can see what you have been doing in this device, actually is currently effectively it's a motor controller in there and a microphone which is collecting sound on the one hand and is sending is creating the electric shock in form of a 3 volt 500 kilohertz whatever signature, and then the app actually is controlling the motor controller in order to send that to release the shock and also collect the feedback, and then the data is pre-processed in the phone, because when we listen to with a, I think it's 193 kilohertz microphone, so we have a lot of noise, so we need to clean up that noise and figure out what has been adjusted, if it has been adjusted, so that you know, because you cannot see it, it's too small actually to see it, so we need to have the audio involved, and of course there's some serious computing needed, and that's why we decided for going with a phone application to use the computing power of the phone and don't need to put some stupid buttons or extra display on this device. And this is very important. And also usability was a big question. So how do you put it on that? Actually, how do you put that thing on this device? So on the left side you have actually the pole which you need. On the other side you have the other poles for the case. And here actually the crown is actually hitting a microphone, because the noise comes out from the crown in the best possible way. And so in this way we hope that we can actually have clear signals and work our way towards what you call the closed loop regulation mechanism. But that doesn't mean that that is a time graph or something like this. This is really to see, okay, adjustment has been done, how much has been done. The fact that the watch is off is still something everybody needs to figure out by himself, because every watch wears different on every wrist. So very happy with that. You see a big change from what people saw in our CGIs, in our early concepts, because we have done some tests, mock-ups, and figured out, can you put that thing on the watch, or the connecting spots should be opposite of the crown because it's more user-friendly. So we built in a little bit inside of a plate where we connect the outside to the inside. These are the things which you start thinking about. And what people don't know, we have a relatively large software team operating out of Taiwan. Our profit digits friends who build software for us, also when people buy a watch, then you actually very likely buy a watch through our software application. They are also in charge of building this HORAGE app MicroReg version. It is primarily dedicated to do that. And there you have different, we are actually logging the amount of adjustments you have been done. You can name them by yourself. So as I said, there is no hardwired or remote wired server exercise needed. Even if there's no internet, that doesn't matter. You can do that and use this phone as an extended computing device in order to power our device. That's pretty much it.
And primarily that's because otherwise we would have to build all of that computational power into the tool, which of course then makes it a very complicated and of course expensive tool. And the idea here is the tool itself will have the minimum number of functions and technical features that it needs to work, and then it leverages or utilizes the CPU power of your phone. It's not being used as a communication device, as a storage device, or as a transmission device. It's merely been used for its computational power. So no fear that we are snooping. None of that's going on. It's all just being held on the device itself.
Is there any questions, stuff like that?
Yeah, just having a look. I think we've managed to answer most of them as we've been going through. I think we've caught most of the questions. Of course, if anyone has any questions in the audience, please do put them into the chat. We've got a couple other little bits. Is there any more slides to show, Andy, that we've missed out so far?
No, we didn't have too many slides this time because we wanted to
We just wanted to
primarily
show things happening
show
in real time.
stuff happening. I think I showed that already. As I said, I mean, it's hard perhaps for externals to understand how important this is for us as a company in making movements. Next steps are just continue to work on that, make more of these early samples. I think in probably 3 weeks, Silvan is confident that he put it into the watch. We're still discussing with the case maker about the connecting plate inside, how to fix that and how to make it easy to assemble. I have actually a couple of other slides, by the way, which might be very interesting for the people to look at. It's this kind of version 1, version 2 transition thing. I think for people, basically, I guess people like watching technical things, so I can do that. So probably a couple of slides to see the challenge coming, version 1, version 2, where are these small details? Of course, it's written in German, but it says basically, the screws were too small here, we needed bigger screw heads in order to be more defined. We needed to optimize that shape in order to make it producible. So these are version 1, version 2 questions, and that is some really very small stuff. The slider or the runner, how you call it, I mean, can you actually machine that? Is the positioning mechanism correct? Because we are not allowed to have any play in there. Small details like that, that's a typical machining exercise experience question. We don't want burrs, we don't want too small reamers. If we have that, we need to make sure that we get rid of that. We have more wall thickness in the one or the other area. So all these small details keep us from continuously repeating the design stage in order to get better and better prior to making stuff. And that is something I think in today's world, as I said, I mean, we are the tech guys of the watch industry. I would say we are using first-class engineering, advanced computing technology in order to make our stuff, combined with a lot of experience of 15 years of making parts. And if you don't have that, you are going to need a long time, and not as we did less than a year, to get to something where I always said, okay, that should be the final outcome, but it works faster than we thought. So there's many then these springs, optimizing that spring. Why is that spring there, by the way? This kind of this spawn neck needle. We don't want tolerances. We can't produce as precise as we want it, so we need to push the whole system into one direction, where during manufacturing on the one side we can be 100% sure that this is the zero spot of the whole system. So even if you get a shock, it will move into the original position. These are things you learn when you actually do that stuff. That was probably one of the most tricky things here. I mean, this was the first thing, easy. Everybody says, there's no problem. We make a couple of plates there and connect something. But when you think very hard, then you think about, okay, that's a mechanical movement. We need to make sure that this mechanical movement can be disassembled by a non-professional, non-HORAGE person in 100 years from now and put back together, and without having to solder or glue anything. So that is some serious challenge. And so the first thing, it looked cool, but it's basically, you can't do it like that. And then we were trying to get our head around how do you actually connect something without the watchmaker having to do permanent fixation operations, because that's what we don't want. So there's a lot of traditional watchmaking thinking behind that, even if there's a little bit of a plate. Or even the worst challenge actually was, how do you fix something with a screw without actually applying torque, because that actuator wants to be perfectly straight, and that perfectly straight actuator wants to be there also when someone else has taken it apart. So somewhere in a store or a watchmaker, the people need to be able to put it back together without our assistance or without specific tooling involved. That was our goal, and I think we achieved that goal in the best possible way. You might think, oh, that's how it is now. No, of course, the version number 3. And the version number 3 is the one which you saw before on that slide, so you can compare that again. That obviously from the rear looks a little bit different, and out of a sudden Silvan and Marcus came up with a cool idea and said, yeah, that's how we could actually, with a very simple way of fixing it into that movement and holding the torque on the right place. So just that you get a little bit of an idea of how much brain exercise actually goes into that whole thing. Yeah.
Yep, the smallest parts, and sometimes what you believe are the easiest parts that will be the easy solutions turn out to not necessarily be that way. That is usually the problem within watchmaking. Do you have the wee video, Andy? We had the little video, obviously, of that first component coming off of the lathe as well.
Yeah. Let me show that.
That's definitely worth seeing some of these parts to give you a kind of idea of scale of some of these parts.
Wait a second, you just continue talking a little bit.
Yeah, I will continue. So the whole team has been working hard on this. The next steps are going to be obviously having a case with those contact points integrated into it so that we can fit these calibers into it, and then see if we can still make the adjustments by just applying the tool to the touch points on the case. At the moment, all of the tooling is being directly connected to the contact points on the caliber. We now need to make sure that we can fit these calibers into a case and that everything lines up so that when we do touch those contact points, then everything comes alive at that point as well. So
people don't get bored, I show a watch here.
Yeah.
Until I have actually the production. Wait, now I have it.
As a question there, I'll answer while you're looking. Yes, so Bernie's asking, good design decision to employ a cell phone as the controlling interface, Android and iOS. Yes, absolutely, we will be supporting Android and iOS. We had lots of discussions about what we would use in terms of feature sets, but we will support, pretty modern, but also a good few-year-old phones as well. We did make a decision to stick with the USB-C interface. I think even Apple now has been on USB-C for quite a number of years as well. And by the time, of course, this product comes to market in later 2026, we will also see another couple of generations of iPhone back on USB-C. And of course, Android's been on USB-C now for many years.
I have no that.
Here we go.
Thing
Andy's
here.
found the video. It's just coming on now. So that's the tip of a pair of tweezers. This is one of the components of the MicroReg assembly. So Andy will now play the video.
Yeah, I muted the sound. I mean, you can see it in our Instagram, I think, or something like that.
I think it's been on Instagram stories, yes. Yeah. I think it's been on both.
You have to imagine it's insanely small. And the cool thing is, we in the beginning, we thought, okay, we need to do that outside. We need to go to a manufacturer, and then Jörg said, no, just try it. We use our Citizen R04 lathe, which is equipped with a second spindle and which can actually machine this little, actually it's a runner screw. The correct term, I think, is a runner screw and a runner screw. And Leo was freaking out because it's so small, it's hard to film that thing on this machine. And so basically, besides some flat parts, we are able to make these parts also inside of our own facility. And it's fascinating. And tuck, cut off. That's how it is.
That's it being taken out. There we go.
Cutting clean. And
on to the next one.
Yeah. That's where it is.
Yes, that is a tiny component being made on not such a tiny machine, it has to be said. The machine is rather large. It would not fit in your average living room. But yes, that is part and parcel. Big machines making very small, very high precision parts.
Yep, correct. Yeah.
So I think that's us coming into rounding up everything that we wanted to talk about on this.
I think it's interesting here to hear something, that actually ticks its way.
Yeah.
So we're not just making some nice movies on stuff which doesn't do anything. We are effectively already figuring out what is it actually doing. There will be a lot of work going into control algorithms, control mechanisms, figuring out what actually is really happening in there. But the good thing is that part of the product is something which is an ongoing improvement, I would say. That is the nature of software. Software actually allows to do updates without having hardware around. And I hope we are getting more and more sophisticated over time, understanding all these regulation mechanisms and what actually really happens in there. And having a lot of customers out there who contribute to what we do is very helpful at the end of the day. Yeah? I wouldn't say you're guinea pigs, but we need first products on first wrists in order to get enough volume going and really understand and be able to scale the whole project. Yeah,
absolutely. So I think we've managed to answer all of the questions. Thanks for being so engaged in the comments and asking all the questions. We will be back very shortly in the coming weeks with more updates, of course, on MicroReg. And I'm sure there'll be a couple of other topics that we will be discussing as well. But yes, next steps will be new cases, the next generation, and before that we will have the final or reasonably final time telling discs. So for all of you that have been waiting to see that disc that will allow you to tell the time on the front of the watch to the nearest minute, that will be with us in the very near future. Of course, you can keep up to date with us on our Instagram channel. We put content on there every single day. Also, we are beginning to play on TikTok. Leo's getting his hand around that. And if you're more a fan of LinkedIn, we are posting on there regularly also. So do follow us on any of those channels and you can keep yourself up to date. We have a habit of posting videos as soon as we have them and any photographs of things as they come out. But we will do regular 45-minute updates with you every week, every couple of weeks on bigger topics such as this. So thank you all very much for joining in.
By the way,
Any
I have
last
something
words,
else
Andy?
to show. Yeah, just fresh from the press.
There we go.
What is
so
that?
Yeah, anyone following us know that one of our other big projects was Mission Independence, which was the Autark tourbillon. This was the combining of our hand-wind tourbillon caliber with our K2 MicroRotor, which resulted in the KTMR, the MicroRotor tourbillon caliber, and the first watch to feature that being the Autark tourbillon. We delivered all of those pre-orders by pretty much the end of 2024, and we've just had a slight refresh. We've added in one new dial, that being this galactic blue. This is using a similar granny effect on it to the gradient grey dial, without the power reserve this time, and in this really beautiful deep outer space blue on there as well. It's an amazing dial, I agree.
Well, good. I think that's a good end to today's show, I would say.
Absolutely. So thank you all for joining in. And we will. Oh, Andy's coming back.
No, we want to end with something. How do we want to end here? Techie. Do we want to end techie? Okay, good. No, I probably we do it like this. You know, I want to see you in your full.
Oh my glory. One last question. Yeah, there was, I think it was Matt's asking, is the watch tire steel? If he's referring to the Revolution 3, it is in steel. If you're referring to the Autark tourbillon we showed at the end, that's in grade 5 titanium. Perfect. Well, thanks all for joining us. We've managed to get through this one with no crashes and with good audio, so that's good omens for this week. And of course, if any of you are in and around the San Francisco area this coming weekend, please do come and see us at Wind Up. You'll be able to see these prototypes and you'll be able to see these tech stuff in live as we'll have them with us. So thank you very much, everyone, and we'll catch you again next time.
And see you in San Francisco.